Hello and welcome to a new video about Wittgenstein's Tractatus. My name is Victor Gijsbers and I teach philosophy at Leiden University in the Netherlands. In this video I want to take a look at the final part of the propositions 4, starting with 4.2. So here is 4.2. The sense of a proposition is its agreement and disagreement with possibilities of existence and non-existence of states of affairs. Okay, the sense of a proposition, right? We're talking about the meaning, the sense of a proposition. And what a proposition does is it agrees or disagrees with certain possibilities of existence and non-existence of states of affairs. Let's start with the simplest case, which Wittgenstein refers to in 4.21. The simplest kind of proposition, an elementary proposition, asserts the existence of a state of affairs. Right, so I can have a proposition which, these elementary propositions, they basically consist of names in a certain constellation, which is a picture of a state of affairs in reality. And so this simple kind of proposition, this elementary proposition, gives me a picture of a state of affairs. Right, and it tells me that that state of affairs exists. And it's true, as Wittgenstein will tell us a little bit later, it's true if that state of affairs really exists, and it's false if that state of affairs doesn't exist. Okay, so that's how an elementary proposition works. But there are also more complicated propositions, right? So for instance, suppose that I have two different elementary propositions, let's call them P and Q. Well, I could also have a more complicated proposition which says P and Q, right? That actually gives me like two states of affairs and tells me that both of them obtain. Or I could have a more complicated proposition that says P or Q. So it tells me that at least one of these states of affairs, but maybe not both of them, obtains. Right? It tells me something. It tells me that it can't be the case that they both don't obtain. But it doesn't tell me precisely what obtains. But it's a perfectly good sentence. Right? I can say P or Q and I determine something about the world. I agree with certain possibilities of the existence and non-existence of states of affairs. When I say P or Q, I agree with P and not Q. I agree with Q and not P. I agree with P and Q. I don't agree with neither P nor Q. I mean, that's something that I'm disagreeing with. I'm asserting that that's not the case. And so on. Right? We can make enormously complicated propositions by hanging together these elementary propositions in logical ways, using things like and or and implies and not and so on and so forth. So, the sense of a proposition is its agreement and disagreement with possibilities of the existence and non-existence of states of affairs, and we make them by taking these elementary propositions, which simply assert the existence of a state of affairs, and building more complicated constructions out of that. So, let's zoom in a little bit more on this elementary proposition. And what we learn is that, first of all, 4.22, an elementary proposition consists of names. It is a nexus, a concatenation of names. And on the other hand, names also only appear in propositions when they are part of an elementary proposition. That's 4.23. So names can't appear sort of on their own. I mean, they have to appear as part of a picture of a possible state of affairs, which is an elementary proposition. But then these elementary propositions can be used to build these more complex sentences. So that's the basic picture. And one of the things that Wittgenstein is going to tell us about these propositions is especially important for us to take a look at. And that is 4.211. It is a sign of a proposition's being elementary that there can be no elementary proposition contradicting it. So this is something that we really have to think through. It's one of the key moves in the Tractatus, and it's something that Wittgenstein himself later got doubts about, and one of the things that started him on a path that led to rejecting the Tractatus proposition. So 4.211, it is a sign of a proposition's being elementary that there can be no elementary propositions contradicting it. In other words, if I have all the elementary propositions, they are logically independent. The fact that one of them is true or false tells us nothing about which other ones are true or false. And in fact, although Wittgenstein doesn't explicitly say it here, he means this in an even stronger way. Right? Give me any set of these elementary propositions and tell me which of them are true or false. It still tells me nothing about the other elementary propositions. They are completely independent. So I can assign to each elementary proposition the value true or false as I will, as I want, without ever ending up in a contradiction. Any combination of true or false values of these elementary propositions is possible. So why does Wittgenstein think this? Well, I suppose that he has a picture that's a bit like this, right? Let's think about elementary propositions as like very basic pictures of state of affairs. That's basically what they are, right? And so maybe what we're thinking of is we have two objects, let's call them A and B, and maybe they hang together in some relation, let's call it R. So we have ARB, right? That might be an elementary proposition. And now the idea would be that if that's really an elementary proposition, then A is a simple object and B is a simple object and R is some kind of simple or fundamental relation. And that means that ARB tells me nothing about other elementary objects or other like fundamental or basic relations. So if ARB is true, great. That doesn't mean that I know whether BRC is true or ARC. Or take some other relation, let's call it S, whether ASB is true or whether ASC is true. Right? If these are really sort of fundamental objects, and if these are the most basic foundational relations, then supposedly they have nothing to do with each other, right? And so ARB can be true, and any of these other claims about the world that are equally elementary could also just be true or false. We know nothing about that, right? That has not been answered. That freedom is still there. Now, when we think about it a little bit further, this actually generates some pretty tight constraints on what these elementary relations or maybe elementary properties of objects can be. So let's think about properties first. Well, one property that we might like to think about sort of in daily life is a property like color, right? And then we might think, oh, look, here are some elementary claims that we can make about things. We can claim that something is green, and we can claim that something is blue, and we can claim that something is red. And if I claim that something is green, for instance, well, that doesn't tell me anything about the color of other objects. And that's true. But when I say that something is green, and let's assume that I mean that it's all green, right? It's green all over. Well, that is actually incompatible with claiming that it is red all over, right? It can't be the case that something is green all over and red all over. So A is green all over and A is red all over can't both be elementary propositions because they contradict each other. Right? Maybe not sort of formally, logically, but they can't both be true. Right? It can't be the case that something is green all over and red all over. Okay, let's take an example with relations. Suppose that I have a relation, a distance relation. And so I say, oh, A is 1 meter away from B. And, well, that doesn't tell me how far B is away from C, right? So I can say, B is also 1 meter away from C. That's fine. But if A is 1 meter away from B and B is 1 meter away from C, then it really can't be the case that A is 712 meters away from C. Right? If A is 1 meter away from B and B is 1 meter away from C, then the distance between A and C must be somewhere between 0 and 2 meters. It can't be 712. So, distances, it seems like they can't be sort of fundamental relations in Wittgenstein's ontology, because distance claims can actually contradict each other, even when they are about different objects, right? A distance claim about A and B, and a distance claim about B and C, and a distance claim about A and C like 3 of those together can form a triad that can't be true, right? That can't be in the real world. And so something like distance would seem to be out. And then we've got some very good questions about, well, what can the fundamental relations be that Wittgenstein could use in his ontology for the Tractatus? And he doesn't tell us, because he doesn't want to go into that, he doesn't think he knows it. But I think what becomes obvious is that it's not going to be easy to think up any kind of relation that is both sort of contentful enough to create the world and has this feature that it never contradicts other ascriptions of the same relation. So, this is going to be a real problem for Wittgenstein later on, but here in the Tractatus he assumes that that is how things work. That these elementary sentences, these elementary propositions, they can just be true or false, and in any combination, right? They don't say anything about each other. Okay. Well, that means that Wittgenstein can calculate how many possibilities there are for the world to be. And we'll get to that in a second, but Wittgenstein first gives us a kind of an aside about the notion of identity. In particular, he's going to tell us how he is going to use the is sign, the equality sign. And he says, well, I'm going to use the equality sign to mean that one sign, let's call it, so if I say A is B, what I mean is that wherever you write A, you could also write B, right? I'm going to use it as a way to indicate the substitutability of 2 signs. In particular, I'm not going to use it to talk about some kind of substantial notion of identity between objects. So in daily life, we use is a lot to talk about equality, where that equality is identity between objects. So I might tell you that the author of the Tractatus is Wittgenstein, right? And what I mean is, there's the author of the Tractatus, that's one thing we could be talking about. There's Wittgenstein, that's another thing, not the best word maybe, thing. That's another thing that we could be talking about. Oh, they're actually the same thing, right? And by telling you that, I'm giving you some new information. Wittgenstein thinks that, like, the real underlying language, right? I mean, the language that that consists of these elementary names for elementary objects, you can't have any substantial identity claims in there, right? Because if I write down what something is, what I'm talking about, really in terms of the elementary names, and I do that on both sides of the equality sign, well, there just must be the same elementary names, right, in the same constellations on both sides of the equality sign. And just by looking at these terms, I ought to be able to see that they are the exact same, right? If they're not the same, if there's not the same elementary names in them, then they're not the same, right? Then they're different objects. If they are the same object, then I should be seeing the exact same elementary names in the exact same constellation. And so I'm really not saying anything when I'm saying that one is the same as the other. So in a perfect language, both Wittgenstein and the author of the Tractatus would be written in the exact same way, right, as the exact same constellation of elementary objects. No, that's not something that we can use to tell us something new about the world. It can't be a meaningful sentence to say something like Wittgenstein is the author of the Tractatus, meaning there are these 2 objects, but they're actually one object. Doesn't make any sense. When I use is, says Wittgenstein, I'm using it only to introduce new notation. Why? Well, because sometimes you have some very complicated notation and you want to write it in a faster way, right? Just pragmatics. And I'm going to use is to introduce, by definition, new notation that is simpler for use in the system. That's it. That's the only kind of identity that I am going to allow and need in my philosophical theory. So that's why he's talking about identity here and what this story about the is sign is. Okay, so let's go to 4.25. If an elementary proposition is true, the state of affairs exists. If an elementary proposition is false, the state of affairs does not exist. I think that's pretty clear, right? This is the connection that we've already been assuming between truth of propositions on the one hand and the existence of states of affairs on the other hand. 4.26. If all true elementary propositions are given, the result is a complete description of the world. The world is completely described by giving all elementary propositions and adding which of them are true and which false. Right? If I want to tell you what the world is like, all I need to do, I mean, it's probably going to be impossible for anyone to actually do this, right? But in theory, all I need to do is I need to take the elementary propositions and tell of each one of them which is true and which is false. I can't do less than that, right? I can't just indicate for part of the elementary propositions which are true and which are false, because they are logically independent, so you still wouldn't know about the other ones. I have to tell you for each of them whether it's true or false. But I also don't need to do more, right? Because all the more complex sentences are built up out of these elementary propositions in such a way that their truth or falsity can be seen once you know the truth or falsity of the elementary propositions. If I make the more complicated proposition P and Q, well, if you know whether P is true or false and whether Q is true or false, you also know whether this more complicated sentence is true or false. And the same for P or Q, and the same for any more complex sentence. So, taking the elementary propositions and telling us which of them are true and which of them are false, that's a full description of the world. Any of the possible combinations of true and false are a possibility for the world to be, right? Because these sentences are logically independent. That means that we can calculate exactly how many possibilities there are, how many ways there are for the world to be. If there are n elementary sentences, then there are n sentences that can be either true or false. So I have two choices. So I can have two choices here, and two choices there, and two choices there, and that n times. Well, that means that the total possible choices is 2 times 2 times 2 times 2 times 2, and that n times, which is 2 to the power of n. So if there are n elementary propositions, there are 2 to the power of n ways for the world to be. That's what Wittgenstein tells us in 4.27. Unfortunately, Wittgenstein uses a much more complicated mathematical formula, which is equivalent to 2 to the power of n. So basically what Wittgenstein does here is he says, okay, let's count all the ways in which 0 propositions could be true, and then all the ways in which 1 proposition could be true, and then all the ways in which 2 propositions could be true, and then you get his formula. But it's just 2 to the power of n. Right, and I think it's much easier to see why you get that result than working through Wittgenstein's maths over here. All right, so let's go to 4.3. In 4.3 and especially in 4.31, Wittgenstein starts to introduce his truth tables. And those truth tables are going to be used fairly soon to sort of explain how logic works and even define, you could say, the logical connectives. And we're not going to see that in this video, but we're going to see it very soon in the future, because this is in 5.101. Right? 5.101 has this entire table of 16 possible truth combinations with 16 possible logical connectives. And basically this is a kind of explanation that you can probably still find in logic textbooks today. So this use of truth tables in order to explain these logical notions, fairly influential in explaining logic to people. Right, you would, I mean, if you're sort of doing more advanced logic, you wouldn't usually write this kind of stuff out, but it's a good way to get started thinking about logic. So what Wittgenstein is doing here in 4.31 is he is, giving us an overview of the number of possible ways in which a certain amount of sentences can be true or false. Right, and again, we are assuming that these sentences we take them as independent. And so any combinations of truth or false can be is a possibility. And so if I have one sentence, P, one proposition, P, there are 2 possibilities, right? It could be true or it could be false. If I have 2 sentences, P and Q, I have 4 possibilities. Both could be true, one could be false and the other true, or the other way around, or both could be false. right? That's the second table over here. And with 3 sentences, I have, hey, 2 to the power of 3, right? This is this 2 to the power of n that I was just talking about. I have 8 combinations. 4 sentences, I have 2 to the power of 4, 16 combinations, and so on. So, if I have n elementary sentences, then a graph like this could be used to write down all the possible ways that they could be true or false. And then that would be all the ways that the world could be. Right? So if I have n sentences, I have 2 to the power of n rows of different combinations of truths and falses. And each of these rows is one way that the world can be. Well, if that's true, Wittgenstein tells us, then I can also calculate the amount of sentences that there are. Okay, so the amount of elementary sentences is n, right? And that means that the amount of ways that the world can be is 2 to the power of n. Now, the more general idea of a sentence, like sentences in general, tell us something about what the world is like. How do you tell us something about what the world is like? Well, basically what you're going to do is you're going to take all these ways that the world can be and you're going to restrict reality to some of them. You could be extremely precise, right? There could be a sentence that tells me that the world is exactly this, right? This one way that the world can be, that is what is the case. So, for instance, if I have these 3 elementary sentences, P, Q, and R, one thing I could do is I could say they're all true. Or I could say, well, P is false, but Q is true and R is false. I mean, that would be a way to pick out exactly one way for the world to be. And that's something that a sentence can do. But a sentence can also pick out several ways that the world can be and say, oh, it's one of those. Right? I could pick 2 ways for the world to be, or 3, or 4, or 5, or 6, or however many that I like. Another way to think about this is the following. I have here 2 to the power of n ways that the world can be. And when I speak a sentence, I'm basically making a choice for each of these ways that the world can be, whether I allow it or not. So I can say, yeah, this is allowed, this is not allowed, yeah, this is allowed, this is allowed, this is allowed, this is not allowed, this is not allowed, and so on. So for each of these 2 to the power of n ways that the world can be, my sentence will either allow it or exclude it. That means that the number of sentences that I can make, if there are n elementary propositions, well, then there are 2 to the power of n ways for the world to be. And then there are 2 to the power of 2 to the power of n possible sentences that I can speak. Right? Because a possible sentence is just some selection of these ways that the world can be that I allow, where I say of all the other ones that they're not allowed. And so I have to make 2 to the power of n choices, yes or no. And I get 2 to the power of 2 to the power of n possible sentences. Again, if you want to see an example of that, well, you have to look no further than 5.101. In 5.101, Wittgenstein is going to show us all the sentences you could say if you take as basic 2 elementary propositions. If there are 2 elementary propositions, then there are 4 possible ways for the world to be. 2 to the power of 2, but there are going to be 2 to the power of 2 to the power of 2, that is 2 to the power of 4, that is 16 sentences that I can speak. And this for Wittgenstein is going to mean that there are 16 logical connectives that I can create when I have 2 sentences, and they are in table 5.101. So this number 2 to the power of 2 to the power of n is given by Wittgenstein in proposition 4.42. Except that, unfortunately, he again chooses a more difficult way of counting, arriving at a more difficult mathematical formula. But, again, if you do the math, this is the same as 2 to the power of 2 to the power of n. Right? So for one elementary sentence, it's 2 to the power of 2 is 4 ways for the world to be. Is that right? Yeah, that's right. That's right. There are 4 ways for the world to be if you have one sentence. 2 to the power of 1 is 2. And 2 to the power, yeah, that's all right. And for 2 sentences, it's 16. And for 3 sentences, it's already getting kind of large, right? It's 2 to the power of 8. And then we get 2 to the power of 16. And, you know, things are getting large pretty quickly. So these are large numbers if there are many elementary propositions. All right. So what Wittgenstein tells us next is, well, he is going to be worrying, as he does a lot, about the implications of the way that we use language, right? And in particular, he's wondering about, okay, I've now been creating this notation where I talk about true and false all the time. Well, does that commit me to thinking that there are things such as truth and falsity? And his claim is going to be, no, absolutely not. Right? So take the propositional sign, he might say, that we have in 4.442. Right? So if we look at 4.442, what Wittgenstein has given us is a sentence, basically. It doesn't look much like a sentence because it's this truth table, but it is, in fact, a kind of sentence. Right? Suppose that P and Q are both elementary propositions. Right? Then this table gives us the 4 possible combinations of truths or falsity. They could both be true, P could be false and Q could be true, P could be true and Q could be false, or they could both be false. And then the 3rd column, that's where sort of this sentence is really happening. The 3rd column tells us which of these possibilities we allow. There's a T by the ones which we allow, and which of them we exclude. And there's nothing. Could have been an F, to be honest, but there's nothing in the rows that we want to exclude. So this particular sentence here, this proposition here, tells us P and Q could both be true, or maybe P is false and Q is true, or maybe they're both false. That's all allowed, but it's not the case that P is true and Q is false, right? That's not allowed. So that's what this sentence is telling us. And what Wittgenstein says is, well, this is basically just a complicated picture of reality, purely in terms of P and Q and in terms of the objects that P and Q are actually talking about. We are not introducing new objects. True and false are not new objects in the same way that these horizontal and vertical lines are not new objects, right? So it doesn't make any sense to ask, what is truth? Where is it? Or something like that, right? That's just notation. The only thing that I'm committed to ontologically in the world are the objects, the elementary objects that are there in the elementary propositions P and Q. So what we then get, starting from 4.46, is a discussion of something that's fairly important for Wittgenstein, which is tautologies and contradictions. So tautologies are basically sentences that look at all the possibilities for the world to be and say, oh well, it's one of them. Yeah, okay, if you've got all the possibilities for the world to be and you say, oh well, it's one of them, I'm excluding nothing, then you're not really saying anything, right? You're always right, of course. One of the ways that the world could be is the way that the world is. But if you're not saying anything about which one, then yeah, you're right, but you're right by saying nothing, right? It's basically meaningless what you're doing, or at least that's Wittgenstein's analysis here. On the other hand, a contradiction would be the exact opposite of that, right? A contradiction says of all the possibilities that they're not the real one, that they're not the one that obtains, but that means that there's nothing left, and that means that I'm wrong, right? When I express a contradiction, I'm always wrong, but I'm wrong not by sort of making a mistake in what I think the world is like. I'm wrong by speaking a sentence which excludes all possibilities, so which is necessarily wrong, no matter what way the world is like. So that is how Wittgenstein thinks about tautologies and propositions, and he tells us that they say nothing, right? They have no sense, they are meaningless. Tautologies and contradictions lack sense, like a point from which two arrows go out in opposite directions to one another. And I assume that we're thinking about a kind of sign here, right? You come to a sign, it says hospital, and there are two arrows in different directions along this street that goes in two directions, and you're like, okay, this is a meaningless sign, right? It tells me nothing. That's what a tautology and a contradiction are like, in a sense. A tautology points in every direction, a contradiction points in no direction. Something like that, right? These are metaphors. But they're meaningless. And that's kind of important, because usually people thought, well, you know, tautologies are great. They're the truths of logic. Well, they're not much of a truth, Wittgenstein is telling us. They are meaningless. They are not, however, this is 4.4611, they are not, however, nonsensical. Right? We can make a distinction between a contradiction or a tautology on the one hand and something that's really nonsense on the other hand. If I say P or not P, I'm not really saying anything, but at least it sort of is an intelligible part of the system of logic. Whereas if I say flop clock boodle, well, that is not an intelligible part of the system of logic. I mean, that's just nonsense. Right, so there's a distinction there, which for some commentators is actually fairly important for Wittgenstein. This distinction between, on the one hand, having no sense, being senseless or meaningless, and on the other hand, being nonsense. So Wittgenstein gives us a few more metaphors. Some of them are quite nice. Right, he says that. Where is this? He says that, a tautology leaves open to reality the whole of logical space. A contradiction fills the whole of logical space, leaving no point of it for reality. I mean, that's nice, but basically he's reiterating this same view of what a tautology or a contradiction consists in. So, final thing that he does in the fours is he tells us a little bit about the general propositional form. Well, that's something that he'll come back to later. For now, he's going to be relatively vague. He's going to tell us that the general form of a proposition is, and this is the final sentence of 4.5, the general form of a proposition is, this is how things stand, right? Such and such is the case. This is the situation. Right? That's what the general form of a proposition is. And of course, we've already seen, or I've already talked a little bit about how these propositions are generated. Right? You take all the elementary propositions, that's what 4.51 tells us. You take all the elementary propositions, and now you are going to sort of logically construct all combinations from them. And then you get all the other possible sentences, all the other possible propositions. And we're going to learn more about that in the rest of the Tractatus. And then Wittgenstein here ends the fours by saying that the general propositional form is a variable. And this harkens back to what he did in the 4.1s, where he told us that like these formal concepts, like a thing, for instance, we've got to think of them as a variable. Right? There's not really a concept of thing where we can sort of intelligibly say that a table is a thing or wonder about what things really are. There is an x such that x is a table. That's, the x, the variable over there. That is sort of the way that thing, the notion of a thing in general, appears in our logical notation, in our logical language. In the same way, the general propositional form is going to function like a kind of variable in which we can substitute different propositions, right? Where we can range across all the propositions and talk about them. How we're going to do that, and how we have to think about these logical construction of propositions and so on, well, that's a theme that's going to be with us throughout the fives, and if I'm not mistaken, also the sixes. But that's for later videos.